Great. Well, great to meet you. My name is Paul Yuknovich. I work on the Visual Studio product team, and I'm one of the program managers. My team is in charge of actually designing and building all the cloud tools for Azure inside of Visual Studio. So today, I'm really excited to talk to you guys about kind of a topic that's a bit more advanced than the typical, hello world topics you maybe see the product team do. We want to go through continuous delivery with your Windows Azure cloud services. And what I really mean by that is, after we've built and tested and published our application using Visual Studio for the first time, what we want to do is actually automate absolutely every step of the process, from building to testing and to actually doing the push up into Azure. And so what we're going to do today is I'm going to show you the really kind of simple continuous delivery CI and push process. And then we'll actually take a really deep dive into what are the different elements in the CI and continuous delivery process. And my hope is that you can use either the whole process or you can use the right bits and the right modules in this process that work for your custom environment and for your custom situation. All right? So I just want to take a moment to get to know all of you in the crowd. So who here has spent some quality time with Azure already? Okay, good group. Of you folks, who's actually deployed something into Azure already? Okay. Who's attempted to set up your own automation or delivery process? Oh, that's really great. Okay, so what I'm seeing from the room is actually there's a mix of folks who are probably a bit newer to Azure, and then there's a mix of folks here who have actually gone pretty far with Azure, and I'll try to do some things that are great for everyone. I'll do a bit of overview, but we'll also do some pretty deep tips and tricks. And just keeping in mind that this is kind of an advanced session. Hopefully we strike the right balance. Does that sound okay with you guys? All right. So in terms of the goals, what we really want to be able to do is automate every step of the delivery process, in particular for cloud services. And just spend a moment on that. Cloud services, as you've probably seen from the keynote with Scott Guthrie and also with Mark Rasinovich, they talked about the different compute options that we have now. And cloud services, that's the PaaS option that we've had with Windows Azure for a few years now. Right? So that's where you bring your own application, you focus on the app, and you let Microsoft and Windows Azure focus on not only the infrastructure, but also the operating system. Right? So it's really, it's meant to scale infinitely. It's meant to handle your more sophisticated end-tier apps and actually your custom OS installations. The second thing is I want to be able to integrate with your overall application development lifecycle. And I'm recognizing also that your lifecycle process might be pretty custom. And so, like I said, I want to make sure that we show you some things that you can integrate with your process. And that's where the third goal comes in. Let's show you the different ways you can tweak and tune this so that it works with your unique environment. So of the things that we're going to hit, first thing, I'll give you just that bit of overview. We'll actually go and configure our build server. The build server could be, I'm going to assume at first it's really, just kind of a vanilla build system. And then what we'll do is we'll wire in TFS. TFS is optional for this topic, but it really helps if you have it. It does a lot of the heavy lifting for us. We'll go through the MS build process so that we can create packages for the cloud with MS build, and we know completely how to do that. We'll use PowerShell as a way to push today, right now, to Windows Azure. And PowerShell is basically a convenience layer that will sit on top of the service management REST APIs that already exist and that we all have access to. All right. And then what we'll do is we'll build and deploy using a combination of either MS build and PowerShell or using TFS team build. And then at the end, what we'll do is we'll use the same process that's actually built into the Team Foundation service, or basically the hosted service we have for TFS. And what you'll see is that hosted TFS actually automates by default this delivery process for you, and it gives you a working build definition that you can go ahead and use. So if you haven't done any of this and you're comfortable with using the cloud, you can use actually the cloud to build and push to the cloud, and it's quite easy. And then, as I mentioned, throughout, we're going to talk about customizations and best practices that will help with your unique situation. So let's just jump into the overview. So what we'll do is we'll go through the persona of wearing a number of different hats. Actually, I'm just curious, who in the room typically wears the developer hat a lot of the times? Okay, that's a lot of us. Who wears kind of the IT pro hat some of the times? How about management and operations? Yep. How about everything? Wears all the hats. Okay, I like that. So what we'll do, we'll start out thinking about the developer machine, all right? And obviously we have Visual Studio, we have the Windows Azure SDK for .NET. That's the minimum of what we need to do development against Windows Azure. Actually, you don't even need Visual Studio, but it's obviously a lot better, and I'd be negligent not to show it as the Visual Studio PM. But what we do, obviously, we build the projects, we F5, we go through that iterative development process, and then we can even make use of unit tests with our favorite test frameworks, manual tests, coded UI tests, all that good stuff, and we'll build up that application. So that's really the dev phase. Then we check in, and a lot of us are using source code management. So we can use something like TFS, if that's our system. We could use Subversion, Git. There's all kinds of great options out there. So we can check into our source code management. And then there's actually a set of build targets and scripts that we're going to have on the build server that not only know how to handle our web applications that go to the cloud, but also know the Azure-specific things that we need to build, like how to build that cloud service package. From the build server, we can basically do that either nightly build, some kind of a rolling build, or we can actually do CI, continuous integration. And all I mean by that is basically every check-in will result in a build that's run through tests. Okay? At that point, we can have like a TFS build server or some kind of environment where our tests in build will be performed. And once that cloud package is built, that CSPKG, and that's basically, it's kind of like MSI is on-premise. We have the CSPKG, which is our deployment package for Azure. We're pushing that into the actual Azure environment. And that's where a lot of our integration testing and real-life testing with warm-blooded testers will actually happen. I'd like to take a survey from you. How many folks do the majority of your testing kind of locally in some kind of local environment like the emulator? Okay, that's a lot of folks. And maybe this resonates with you. That actually minimizes costs. It actually minimizes time, right? Because we're not spending the time to deploy to Azure, and we're also not paying for our testing to be done actually live in Azure. Is that probably why we're doing it that way? Okay. Also, there's integration testing inside of Azure. Who's actually doing that? Right? A few less folks, but what I tend to hear is, sometimes you feel a little bit better when you try that true integration test actually in Azure, because there are a few environmental differences, whether it's identity, what's actually installed. Your assumptions about what's installed on the dev machine actually might be a little bit different than what's in Azure, right? You might have GACT assemblies on your local environment and kind of forgetting that on a fresh ISO of Windows Server, that won't be on the Windows Server. So there are some environmental differences that we'll catch through integration testing. And, we'll go through, again, that natural process of we'll find bugs, we'll fix bugs. Those check in back into our repo. We do another build. If we do continuous integration, that translates immediately into another build, etc. So does this process kind of resonate for most folks? Does this make sense? Okay, so this is essentially what I'm going to show you how to enable in the next hour, and we'll take any questions, or you can slow me down as you like. So with that said, let's actually switch over and do the simplest demo. And really what I want to think about is, even though I'm going to spend some time showing you the nuts and bolts here, I just want to remind everyone that you can take actually the files that I have up on Windows Azure, you can drop it into your build environment today, and you can actually do what I'm going to do in the next 5 minutes without constructing it by hand. But we'll actually show you how it works and make sure that you're feeling comfortable with it. So the first thing, I actually have a really simple MVC application. kind of the Hello World style application. It doesn't really matter how complex that is for the sake of continuous delivery. I've created the Azure project. That's effectively our setup and deployment project for Azure. It also lets us model what the environment is in Azure. So I have things like the role definition, the configuration. It's actually kind of important to note that we have both cloud and local and even test configs. I can have an arbitrary amount of config files that correspond to each environment. And that allows my package actually to be kind of independent of assumptions about each target environment I'm going to go to. For example, I might have different connection strings for databases or to storage accounts for test versus local versus LKG versus production. Okay? And then I've also defined a unit test, a really simple unit test that will test out the controllers in my MVC application. And I just want to make sure that on an API level that it works. I could actually also go ahead and make automated tests, things like coded UI tests. That would be fine too. All right. And then using TFS, if I go to the Team Explorer, all I've done is just set up a build definition. And there's two things I've extended. I've added a process template. A process template is just a XAML workflow file. It literally is, the big boxes and lines kind of a thing. And all that I've done is I've added a few activities to the workflow that know how to load PowerShell. And the PowerShell file will basically do the heavy lifting to build and push to Azure. All right? And as I mentioned, and I have it in the deck so that everyone has a pointer to it, this XAML file and this PowerShell file that I'm referencing are available online right now. You guys can go just drop this in and get it going right away. And you can customize it as you like. Right? And then the actual process that I'm thinking about, well, let's go ahead and make a really simple dev change, and I want to test out that continuous integration process. So let's say I'll go to my settings, and for test, what I want to do, my QA team has changed where the database virtual machine lives. So I want to take note of that, and I'm going to check this change in. And because I have continuous integration set up as a trigger, every check-in will actually correspond to a build, a test, and a deployment. So if I go to the builds menu, I'm actually seeing that this build was automatically triggered. And it was first in line, so it's doing the compilation and the tests. And then what we'll do, it's going to call MS Build, and exactly the way that Visual Studio builds your application and packages it for the cloud, this automation script will absolutely emulate it and just kind of allow you to do it in an emulated fashion. So one thing that we're catching here, we're actually getting the same validation that Visual Studio would give you. So for example, it found in my application that I'm already I already have some connection strings that are pointing to local databases, which isn't a good thing. And the nice thing is it's giving you fast validation and fast failure so that you know and can fix that up before you spend time actually testing a build that you know won't work. All right? And then you can see that we've started to publish already. So that was, as I mentioned, that's actually the simplest kind of drop-in, you can do it right now, approach to continuous delivery. And now what I want to do is spend some more time talking about, well, how did we get there? What are the pieces that we used here? And maybe you don't want that whole flow. Maybe you don't even want TFS. So let's go ahead and see how we can take the pieces we want and drop it in. Actually, let me do a survey of the hands. Who's using TFS right now? Okay. Who's using on-premise TFS? Who's using cloud TFS? Who's thinking about using cloud TFS? Okay, good. So there's a lot of on-premise. And the good thing is I'm going to show you how to do it on-premise, which actually is a bit more complicated. But as I just showed you, that was my on-premise TFS server. You can do it right now. And one of the philosophies, we've probably talked about it a bit, we're going to do work first in the cloud service, because that's something that we can iterate on really, really fast. As we mentioned actually in the keynote, every 2 to 3 weeks, the cloud-based Team Foundation service gets updated. That's incredibly rapid. And then the goal is we take all the best practices from the service, we bring it back into the on-premise Box product, and then we bring it to parity, right? So everything that we've actually done on-premise, we're working to bring that back, and that's why I've kind of created some of these PowerShells and workflows for you, and the goal is to actually put it into TFS. So let's pop back to slides just for a moment or two. All right, so let's talk about a few of the things that I like to think about when setting up the build server. All right, first thing is, a build task typically is fast and disconnected, right? So just doing a pure build, I typically don't like to do anything that could take a long time or that will make a connection to the network or the internet, because that'll make possibly our builds brittle. It's something that we can actually avoid. What I instead do is I do that kind of networking operation as a separate activity after the build, so that I know I always have a good build. I can hand the builds to whoever want to upload it and deploy it. And it's a more reusable unit in our infrastructure. That's what I mean by the second point. Okay. Also, an assumption that I have in mind, and maybe this resonates with you, is that the developers really own kind of the app source code, but they don't own the build server, and they definitely don't own the target environment in Azure, right? There needs to be that allowance for separate concerns, separate ownership. So we have that in mind also with the build server, that there might actually be build server secrets that the developer doesn't know. And we factor this in a way so that you can actually have some secrets that the devs know and some secrets that only the build server and your DevOps folks can know. I set out to make sure that we have really good fidelity with what Visual Studio does, so there's good parity. What developers see will match what you see on the build server. That's a good thing. And then the last thing, like any, I think, modern development, any cloud development, it's really important to have that fast failure and really strong logging so that we can piece together what went wrong. Just a few other kind of considerations that might be good to brainstorm about right now. What are the automation runners that you're using? Is it TFS? Is it MS Build? Is it some third-party product like TeamCity? And based on that, we have different assets here that we're going to plug in. We need to make sure, obviously, that all of the MS Build tools and targets are there. And as I mentioned, there's specific targets for web development, and there's specific targets for the SDK. And all I really mean there is that's extensibility on top of your project that knows how to kind of build that kind of a project. So with an Azure project, I need a build target file that knows how to build the Azure package. And it's actually part of the Windows Azure SDK. We just need to know where to find it, and we need to make sure it's on the MS Build machine. Right? And then obviously any scripts that we need. So like we have some PowerShell scripts that are actually going to do the push to Azure. We need to think through the process identity and access control and secrets. The main secret that we have right now to work with Windows Azure is that management certificate, for good or for bad. We've made it a bit easier over the last year where we have this thing called a publish settings file, and I'm going to show that to you in the demo. The publish settings file encapsulates that certificate, and it's actually a base64 encoded version of the certificate. So in a team setting, you can actually secure and share that file with exactly the right folks, and that'll allow your build process to authenticate with Azure and actually communicate with Azure so it can upload and push a package. So that's probably the most important thing you need. But obviously there's access control with storage, which looks like API tokens. There's identities that we're using with databases. There's a lot of identities that we'll probably think about. I talked about the triggers, lots of different options. You could manually trigger a build. You could do CI, which means every check-in does a build, or you could do a scheduled build. Lots of good options there. And then, maybe we're thinking about the different drop locations we have. I'm going to show you a local drop location and a UNC path drop location, but I know there's a lot of others. Like you can actually check in your drops. Lots of cool things we can do. And then also, as I mentioned about fast failure, with fast failure, there should be strong logging. And what we want to do is actually pipe the output of our logs to the right place where we can go find them, whether that's your build server logs, TFS logs, or even some Azure storage account. All really good options. And it really might vary based on your own requirements. Okay, and spending a lot of time on the build server. Also, I'll just point out that a prereq is the Framework 4.0 or higher, which includes MS Build. To get the right targets, you need the Windows Azure SDK, and you need the Windows Azure tools, which is part of the SDK. Just one thing I'll say is don't worry. You don't actually have to install Visual Studio on your build server. All you need is the Visual Studio tools that are contained in the Windows Azure SDK, and we'll install just the targets you need for build. We won't actually require Visual Studio to be there. So that's something we've relaxed. So it's a really just minimal, small, thin footprint on your build machines. And then just for your own future reference, those are the build paths for either VS10 or VS12, where you're going to find the targets that you need. So if you need to manually copy, let's say, the web build target, you're going to find it in either of those folders. All right? Don't worry, you don't have to remember it. So let's kind of switch gears and let's think about how do we actually build that CSPKG? How do we build that cloud package? All we really need to do is make sure that we're in the path where MS Build can be found, and that we're actually in the path where we're going to find our solution or our project to build, and then we just call MS Build, passing in a target, right? And the target in this case would be target:publish or T:publish. And that's all we need to do to tell MS Build to call the publish target on any CC proj or any cloud project that it finds. Then I just have a few notes for you, right? So this output will be identical to the Visual Studio package output. And then we can also use these same MS Build arguments in conjunction with any other runner that we may use. So if you have your own scripting environment, you can just call this in your script. If you use TFS, there's actually a native spot in our build definitions to say, here's the custom MS Build arguments I want to pass in, and that's where I'm going to pass in that bolded /target publish. So far, so good? Any questions? Okay. A few optional parameters, and these will be pretty handy for you. As I showed in the first demo, we actually have multiple configs typically with Azure. We might have test config versus production config. You can override the default config, which is cloud, to be your own custom config just by saying /p, which is a property for MS Build, target profile equals, and then the name, the friendly name of your config file, right? So you saw in my project, I think I had test2. So I would just pass in test2 here, and that will use that custom environment. And that's, again, going to swap out all the connection strings that I would use for production and swap in the ones that I would use for test, because they actually might be different. All right. Another thing I can do, which is pretty useful, is I can override the publish location. So for example, typically MS Build will just dump it in that bin subdirectory /up publish, and it can be a really deep and kind of ugly file structure. Actually, I saw a few people nod their heads. So if you don't want that deep and ugly file structure, you can just set your own publish folder. So publish dir equals a UNC path equals a relative path, whatever you want, and then we'll build into that location and give you a really clean, well-known, predictable place to find your package. So I don't bore you to death with PowerPoint, let's actually go and interact with this a little bit and try it. All right, so the first thing I'll do is we'll come back to Visual Studio, and actually, let's have a little more fun. Let's do this from scratch. So we'll create a new project. We'll pick a cloud project, and so that means I've installed Windows Azure SDK on my machine. I can add front ends like an MVC web role. I'll add a back end like a worker role. And now I'm going to build out that cloud service. I just have a few options here. So my MVC, I want that to be an internet application. And what we'll do in this wizard is we'll create your MVC application. We'll create the worker role project, which looks like a class library, and we'll stitch it all together using that Azure project, which models the cloud service and knows how to package and deploy it. All right. So now, as I can see, I've got this MVC application. You know, if I run it, it will run in the Windows Azure emulator, which is important because that can simulate storage. It can also simulate any load balancing behavior that I might have as soon as I have multi-instances of this application. And I'm doing it for the first time, so it's cold. Okay. While it's doing that, let's lift the path for this project. And I'm going to open a command line. So in Windows 8, I can type in CMD. And the one I want, there's a bunch of command prompts. There's almost a proliferation of them. But because Visual Studio itself, and MS Build in this case is x86, it's actually 32-bit. We'll use the 32-bit command prompt. And then what we'll do, we'll just drop into the directory. And I can see now I have my Windows Azure project, the MVC web role, any NuGet packages in the actual solution. And now we'll just call MS Build. MS Build, by default, it'll find the solutions and projects in the folder, and it'll go ahead and build it. That was incredibly rapid, but if I look at what it did, we created this bin folder, but we basically just built the constituent projects. Like I built the worker role. When I peek into the Azure project, we're actually seeing that it actually didn't build the package. And for performance reasons, MS Build and Build by default won't create that package. It's a larger operation. It can take time. And we thought it would really annoy the heck out of you guys as developers if we're constantly building packages when you don't want it. So instead, what we have an MS Build command and an explicit Visual Studio command. And we're debugging, so let's stop debugging. That emulates the same process of doing a right-click on the Azure project and doing a package. Right? So when we do a package, we pick the config, we pick the solution config, and this drives the web config transform in your MVC project. I hit package, right? And this is that process that takes several more seconds, maybe about 15 seconds on average. And not only do we do a build, but we're actually creating that CS pack, which is the deployment unit. As I mentioned, if we did this on every build, it would probably drive you nuts. So that's why we don't do it. Okay? And what I expect to see from Visual Studio is the config file and the CS package, right? And this is actually a 10 megabyte guy that has everything I need to model it inside of Azure. So coming back to the command line, if I want to emulate that exact behavior from Visual Studio, instead of just calling MS Build, what I'm going to do is call MS Build /t publish. Let's make that a little bit bigger. Well, it's carrying on to 2 lines. Sorry about that. But anyway, /t publish. And now it's going to do some more stuff. It's found that CC proj, which is basically that Windows Azure project, and it's going to build that Azure package, and it's going to transform all the config settings based on the target config that we've chosen. All right? And the cool thing, actually, is we get even the same validation that we get in Visual Studio. So Visual Studio will complain about the connection strings because they're set to local connection strings. And it'll say, hey, these connection strings actually aren't going to work in Azure. You need to go actually set them. And so one best practice I'll actually share with you, kind of like, as developers, we usually hit F5 to test out our application. I actually like to publish the application first in Visual Studio. Right? So we can import our published settings. Actually, let me just take a moment and talk about that. Who here is familiar with published settings? Folks? A few folks? That's good. Where do I have one? Okay, here's some. As I mentioned, we need a way to basically have Visual Studio and your build server work with your Azure subscription, work with your account. What you'd need to do in the old days is you'd need to understand your subscription ID, you'd need to provision a certificate, you'd need to upload the certificate with the right secret, and make sure that both the client and the service have matching certificates, and then you can finally talk. What we did instead is we just simply offer a link that's up on the management portal where you can download your published settings file, and the published settings file has the encoded management certificate, and then Visual Studio and our PowerShell tools can import this file. It's actually becoming kind of a standard format for Azure. You can import this, and that gives your system everything it needs to know. It will install the cert in the user store for you. Also, this file can be shared by the developers or the build machines that should have access to the secret. Right? So rather than having every developer go do this process over and over, the developers who should have it, you can give this published settings file, and that's all they need. Right? And so basically, we just import the published settings, and as you can see, we support one or more subscriptions. We're actually finding it's pretty common to co-admin multiple subscriptions. Pick the right subscription. We'll see into your subscription now, so I'm actually enumerating what's in Azure. And have a few good options here. Let's do Europe continuous delivery. We'll publish to production. We'll pick the release config, cloud config. We can enable remote desktop, which is really handy. I can pick my storage account that's actually in Europe. It's actually down the street. And we'll go ahead and publish. And like I said, this is the way that we're just going to find any of those publish issues manually before we go into automation and pull our hair out trying to figure out what could be going wrong. The other thing that's really powerful is Visual Studio will automatically transform the default connection strings that are used for Azure. It will transform them for you as a one-time thing and persist those values actually into your config file. Namely, that's your diagnostics connection string to storage and your caching connection strings for storage. And it will actually use the published storage account to be the storage account that you use for diagnostics. And if that's a behavior you don't like, you can always just override what those settings are in each role. So I could open a role, and if I don't like the value that Visual Studio set for this connection string, like if I go to cloud, I can see now that it's using that published storage account. If I drop this open, you can just go ahead and override it with a different account that's appropriate for you. But the nice thing is right away we'll have a working app. Right away we'll have appropriate cloud settings, and we know that automation won't choke when it hits this. All right. So now that we've done that, the next time I do an MS build, I'm going to expect to see less warnings. Okay. We still have some connection strings actually in the MVC app that are pointing to local, but we did eliminate the diagnostics connection string pointing to a local storage. So that's a good thing. So we've reduced those errors. We got that fast failure that we were talking about. Any questions on this? So that was kind of the MS build side of things. You can plug in this MS build command into your own scripting, into TeamCity, TFS, any environment that you're using. And you can get CI working right away. Okay, so let's pop back to slides. So the next stage after we've done a build is how do we deploy, right? And I personally think the easiest way to deploy through automation is using PowerShell. As I mentioned before, PowerShell is that convenience layer that sits on top of the CLI REST APIs that we have. And it now has conveniences like we can load that published settings file that we saw before, so we don't need to fight with certificates to get our PowerShell working. We can get the build output exactly the same as Visual Studio has. Other things that we just want to make sure we've done, we want to make sure that there's a storage account. And just so you know, storage account, kind of as an implementation detail, is used by the PowerShell script to upload your package into Azure. And then Azure needs to deploy from that blob that's sitting in your storage account. That's what it uses to actually provision the virtual machine in Azure. It's an implementation detail, but right now it's an implementation detail you need to know. So you need a working storage account. Best practice, I always recommend use the same data center, like West Europe. Use West Europe for both your cloud service container and your storage account so that you're not paying for networking egress and ingress between data centers. You also need to have a cloud service container. There's a number of ways to do that. Visual Studio, through that first publish, will create it for you if you haven't done it. It'll actually create the storage account for you too. But you can also use that new management portal that you've probably seen a whole bunch this week, and you can easily quick create a cloud service and quick create a storage account, and you're off and running. And then here's a tip that you might trip over. You need an additional certificate to be created and uploaded if you're going to do either SSL or RDP for remote desktop. RDP you'll probably find is one of the more common ways that you're going to diagnose your guest VM, remote into the VM, actually see what the logs are saying, see what's up with the environment. So in that case, I'll show you in just a second, but we'll create and upload a certificate before actually attempting to use PowerShell or CI in automation. And as I mentioned, if you publish with Visual Studio Cloud Tools first, we'll find just about everything that you're missing, and we'll provision it on the fly, so it's something that's already working by the time you try to automate it. Okay, so let's this is just for your reference. I won't actually show you how to do it, but you can use these PowerShell commands to create cloud service containers or to create storage accounts, and it has all the parameters that you'd expect. Like the data center, I was saying West US, but if I were here, I would do it in West Europe. You need a unique DNS name for your service name and a unique DNS name for your storage account. And if you're not sure which locations or data centers or affinity groups you have for your particular subscription, just call that get-azure location or get-azure affinity group, and you're off and running. I probably didn't mention it. These commandlets, like new Azure service, get Azure location, get Azure service, they're all commandlets that get installed as a part of Windows Azure PowerShell, and I have a link to that in the deck in the slides. Just go grab Windows Azure PowerShell. The latest version is 0.6.0, and if you have that, you have all these commandlets that I'm showing you here, and you have these nice one-liners to do things in Azure. Also, we talked about that RDP scenario, the remote desktop scenario. All you have to do to kind of enable RDP certificates is first, if you're using Visual Studio, we'll automatically set up remote desktop for you, and we'll automatically create a certificate if you don't have one. You can also override the certificate we use if you have very specific things that you need. But however you created it, what you'll be doing is you'll look in your CS config file for the target environment, because each environment actually might have different certs. And you'll find this thumbprint, which I've highlighted in blue. And then you'll use that thumbprint as the basis for the next PowerShell commandlet call that I have below, where you add Azure certificate, and we're pointing into the current user /my. All that means is it's the user store, the my user store for certificates. And we're going to basically look into your local store, find that certificate, and upload it to Azure into that particular slot. And just so you know, each slot in Azure needs to have the certificate. I think a decision was made not to make the certificates global so that there's separation of secrets and separation of concerns for each environment. Make sense? Any questions? All right. You can actually also use the portal. You could upload the certificate to the portal, but I think it's a lot easier doing it this way. And then the grand finale is we're just going to execute this PowerShell script. And as I mentioned, I have this up online today. You don't need to re-engineer it. But this PowerShell script will basically do exactly what Visual Studio does, from creating a new deployment to upgrading a deployment to finding the build output and the build status and piping it out to the PowerShell output window. We do all that stuff for you. And I think about two scenarios, and these are the scenarios I hear the most. Scenario one is we want to deploy our application into the staging slot of a cloud service, right? And the staging slot, if you're familiar with it, it has this really long URL, it looks like a GUID. It's pretty ugly, really hard to guess, incredibly hard to type in. But you can publish into that staging slot, and once that passes tests, you can VIP swap. You can do the IP swap with what's in production for what you have in staging. So if you're feeling pretty confident, for a final push, it's okay to push it into staging. If that looks good, just VIP swap it in. If there's a problem, you can VIP swap it back. That's one approach. Another approach I actually hear pretty often is that that you guys like to have actually separate cloud services and separate environments for testing, pre-production, and production. Just saw some heads nod. So you can do that too. That's no problem. All we're going to do is just change the environment that we're pointing to. We could use the production slot on a different service. So I'd actually provision multiple cloud service containers for each environment that I want to have. And I could even have multiple subscriptions, right? I could have a set of subscriptions that only my testers can see and a set of subscriptions that only the ops for production can see. So you have a lot of flexibility here, maybe even arguably too much flexibility, but I think these are the two main approaches you could think about that will set you up for success. Okay? So that said, let's actually interact a bit with PowerShell. Few things to think about. So I install that Windows Azure PowerShell, and when I do that, what you're going to get is this Windows Azure PowerShell icon, which all it does is call the PowerShell that's built into Windows, and it imports the custom modules and the custom commandlets that you need to work with for Azure. Right? So now I can type in get-azure and hit tab, and I'm going to see that there's a whole bunch of interesting commandlets for Azure. So, and the syntax kind of to keep in mind is get-azure or set-azure tends to have the most interesting commandlets, right? Whether it's working with deployments, working with services, working with roles, working with locations. The thing I like to do, this is my hello world in PowerShell, is I like to make sure I can get to this point, get-azure service. And if my account is connected properly, I'm going to look into my subscription, and I'm going to enumerate the list of cloud service containers that I have. And you can see that actually that I have quite a few. PY TechEd Europe, PY EuroCD. These are my West European containers. I also have some in the US. IaaS virtual machines. And this is just the PowerShell representation of what I can see in the management portal, right? So that's kind of that's sort of step one. What I like to do, I actually like to work in a richer environment. So I use the Windows Azure PowerShell ISE. It's also built into Windows. It's in Windows 8. Actually, in Windows 8, it's a lot faster. And it has a really cool module that lets you search on commands. And so I can type in, get-azure, and I see all the commandlets right away. And I can even inspect a particular one and play with and experiment with the parameters here. So I think this is really handy. And then in the ISE, all I can do is I can just load this PowerShell file. Like I said, it's linked at the end of the talk, so you can just go download it today. But this PowerShell file has just a few different sections. It has some input parameters. In the one that you download, it won't have default values for the parameters. I just did that for the sake of showing you guys in the talk. But you'll put in your own parameters here, like service name, storage account, where packages are built from, all that kind of good stuff. We also emulate Visual Studio, as I had mentioned before. So we have the same deployment label. We give you some options, like do I want to enable deployment upgrade? That means that if we detect that a deployment is already in a slot, we'll instead do an in-place upgrade, which is actually quite a bit faster. It's cheaper because every new deployment costs you an hour. a billing hour. But if you do an in-place update, it doesn't cost you that billing hour. Also, updates won't destroy your VIP, right? So what you might see is when you delete a deployment, you create a new deployment, your VIP is gone. And then if you have other tiers that depend on that Azure service, they need to be reconfigured to point to the new VIP. So it actually eliminates a whole bunch of headaches. I really like to use deployment update. That's also what Visual Studio does. So we tried to simulate all that stuff, and without boring you to death on it, we go through all the steps of publishing, creating new deployments, upgrading deployments, deleting, starting your instances, and we actually do the walk through your instances after deployment, so that we can give you output that looks exactly like this. So you can see the state of starting each of your VMs. And then we do a little bit of extra work to kind of pipe a really nice output to the output window so it identically matches Visual Studio. One thing that I like to say is, this output is pretty much exactly what you need for your ops team and even for our ops team to help you troubleshoot a deployment problem. If there's an error, if we need to look at your deployment ID or even look at your subscription ID, you've got it in this log. All right, so once we've got this, this is kind of a drop-in thing. I can just go ahead and make sure that my parameters look right, or I could call it in the command line, just like we saw in the last slide. And we'll go ahead and run it. One thing that you're going to see today, it's actually a bug in the PowerShell commandlets themselves. They got a little overzealous with the write progress, which creates these little modal dialogues. So apologies, we're working with the PowerShell team to get that eliminated. But if you're seeing all these progress guides that don't complete until the end, that's just a bug, and just know that it's going to go away. If you happen to call this from the command line instead of the ISE, you'll see just the progress bar at the top in the command window, and you won't see all this stuff. So, okay, so it's a little obfuscated right now. We're actually doing some cool things, like we're preparing the deployment. We know the subscription ID. We detected that a deployment already exists in the slot, so therefore we're doing an upgrade. And now we're actually performing the upgrade. And I bet you if I look in the portal, it'll take just a few minutes, we're going to see actually the role state transition into a transitioning state, which means that it's actually in-place upgrading. So that's the PowerShell stuff in a nutshell, and this is an important building block that you can also use, because you can call this PowerShell from your custom scripting environment today. You could call it from TFS. You could call it from TeamCity, wherever you want. This is kind of a nice building block that will do the heavy lifting for Azure for you. Also, there's a few things that we have online as tips. Let's minimize this. But I can just show you it here. In the script, I just kind of pulled it out. We have that line of code that will basically load your publish settings file. I'll just go ahead and run it. But basically, once you download the publish settings file from Azure, you can call this one-liner, import publish settings. And that will load one or more subscriptions that you have and the certificates onto your machine. And that'll basically make your PowerShell aware and able to communicate with Azure. So super handy, super productive. Any questions on the PowerShell? Got a quiet group today? Okay, no problem. So, all right, so now what we'll do, we've talked about the building blocks. We know how to do builds. We know how to deploy using PowerShell. Now what I want to do is wire it all together in a host like TFS. Okay, and I'll show you the on-premise TFS since that's where the most hands came up. So what we're going to do is create a build definition. And for those of you who aren't super familiar with build definitions, it's just kind of like a TFS's answer to a build script. And it allows you to actually run really powerful things like a XAML workflow that will orchestrate the build, running all of your tests, making sure that your tests and quality gates pass, and then proceeding to future phases. And I have a custom workflow file in the next demo that will basically just call the PowerShell and call the MS build that we did in the earlier demos. That's all it does. Okay? And then we're going to set the MS build arguments. We're going to wire up that PowerShell that we just saw, and we're going to customize all of those Azure-specific properties, right? So you can imagine you could have different build definitions for each branch of your code, which could map to, let's say, LKG, servicing, production, pre-production. And in each build definition, you can customize those parameters, like what's the cloud service that you're publishing to. Like we talked about, it might be actually different cloud services for each environment. You could have different settings, different certificates, all that good stuff. So we'll pop right back into the demo. And let's actually create a build definition from scratch. So we'll go into the Team Explorer. And I think let's go nuts here. We'll go a little bit off-road. We'll create a entirely new team project. We'll take the defaults for process template. We'll get a new source control folder as a result. All right. And what the wizard will do, this will provision actually an entirely new team project into our Team Foundation server, which basically is mapped into a database. We're going to get all the default build definitions and all that stuff that we need. And then in just a minute, what we'll do is we'll copy the files into this team project that we need. We'll enlist into it. And then we should be able to, pretty quickly set up this automation. For those of you who've set up continuous delivery already, are you using a similar approach with PowerShell and MS Build? Seeing so-so. Any other approaches you guys are using that I should be aware of? Say one more time. MS Build, right? So you could also have MS Build tasks, right, that could also do the same kind of heavy lifting. Yep, that definitely works too. I think that's perfectly good. It just kind of depends on if you want to have a separation of build versus deploy. And so what I'm doing is actually pretty heavyweight, but it has that flexibility. Any other approaches you guys are using? Any other custom environments? Should be aware of? Okay. I think TFS is sad right now. It's taking a little extra time. I'm about to go to plan B. At least the internet's working today. That makes me happy. Pretty hard for a cloud PM to have a good day when the internet's down. It's really living up to this comment right here. All right. Plan B it is. So we'll use an existing team project, which actually is probably more realistic if a lot of you have team build anyway. We're going to completely ignore that I have this build definition here. In fact, why don't we edit it? And I'm going to turn off the trigger. So right now it's owning the continuous integration. We're going to set it to manual, which will just turn it off. And let's create a new build definition. I'm going to get really mixed up if I do that. So we'll call it PYCD. Someone asked me if that's for Python. I was like, no, it's my initials. Okay. And what we can do here is we'll set the trigger to whatever we want. Continuous integration is okay, I think, for cloud services. It actually can get a little bit chatty if you're doing a lot of check-ins. Because, again, these deployment times, unfortunately, take between 4 to 10 minutes, probably on a good day. It can even take longer on a bad day if the cloud is sad. So Actually, what I oftentimes do is I do a rolling build, let's say a nightly build or a twice-a-day build. But you definitely have the option. You can go between CI or rolling builds. For the sake of drama, we'll do continuous integration. All right, the workspace is already set up. And then because I have TFS already installed, there is actually a build controller. And you can have as many agents or controllers as you want. And we need to actually set where will our build output go by default. I like to do that to a UNC share. So I should have one here. Let's just test it out. There we go. So let's put it right here. All right, nice shared location that all of our testers can get at. And then what I need to do is actually pick an item to build. And that actually reminds me, I don't think we even checked in that totally awesome project that we made. So let's go back. Bet you this guy's done. Oh, it's still not done. Wow, really sad today. Okay, so let's go to recent projects. Should be right there. Okay, here's our MVC web role, worker role. Looks good. We're going to check this into source code control. Oops. $229 items. Wow. We did a lot of coding. Actually, there's a lot of files because of all the NuGet packages that are in the MVC4 app, jQuery, all that kind of good stuff. All right, so now we've got an initial check-in. We should be able to come back to our Team Explorer. Look at the builds. Come back to the editing this build definition. Oh, that was the wrong one. Here it is. I should find it now. Here it is. Okay. So now we're going to build the solution. And actually, I didn't want to set that yet. I forgot a critical step, which is we actually don't want to use the default process template. And remember, the process template is that XAML workflow. What we want to do instead is use an altered workflow. This is the one that I mentioned is open source and up on the web. Default template Azure. And this template just includes a few more critical sections that are Azure aware. So we see that this MISC section was now extended to know about all the same parameters and properties that we knew about in the PowerShell script. Right? So this is basically our funnel to pipe parameters into the build definition, which then pipe into the PowerShell. And just so you know, if you can try out this Azure workflow. Also in the online doc that we put up there, there's the XAML fragment that you can drop into any existing XAML workflow, so you don't have to feel like you have to start over. You can use either the fragment or the whole thing if you just want to drop it in. All right. And then what we do here, we're just going to do a few things. We're going to go to the, it's really hard in this resolution to see. We'll go to Advanced, scroll down. Remember how we did the MS build, passing in the special build arguments? We're going to do the same thing here. So we're going to say /tpublish, which will tell MS build to build the cloud package. And also I want to set the property for the publish directory using that same drop location that we had here, and I'll just add a nice /app.publish, just like Visual Studio does, so that we know that's the exact folder where our cloud packages will go, separate from all the rest of the build output goo that will come out, right? So we set that property. And now what we need to do is just set pretty much every one of these MISC properties. So the cloud config and the package config, they're going to be governed by, actually, let's just go ahead and run it. We actually have a working build definition. We're going to do the CI first, and then we'll do the CD part of the build. So let's just queue up a new build to try it out. It's handy. I have a nice visualization, so I can see that the build's happening, and I can open it up and see the actual trace. It actually refreshes about every 30 seconds, which can be kind of a nail biter when you're seeing if your build works. Would you guys like to be able to customize that refresh rate? Just curious? Yeah, I would too. I'm going to work on that. Okay. All right. And then we're actually seeing already that that target is getting invoked because it's complaining about the same MVC connection string that only the cloud tools know about. So that's a good sign. It must be almost done. Okay, and it's done. So I can always view the log, or I can open the drop folder. I can see that, I mentioned there's a bunch of build output goo. So each website, each role will have its own build output. But I also have this app.publish, and this has the very clean, precise output that we want to do for continuous delivery. So we're most of the way there, right? If you work with a human being who actually does the publish, now you could hand them the package, they could test it, they could upload it, and they're good to go. But we're going to go the final mile, and we're going to grab this as parameters. We're going to push it back into our build definition. So now we'll grab the package. We'll push this in. And we actually need to give it a full path. So let's grab that too. One thing to note that's pretty cool, the way we wrote this this workflow activity, it can understand a number of different things. It can understand relative paths, absolute paths on disk, UNC paths. It can even understand the $/paths in your workspace if you've set up a workspace. So you have all those different options. Okay. Then what we'll do is we'll grab the publish script. I always like to have scripts like that checked in. So if I go to my home, my source code in Explorer, you can see that all the continuous delivery scripts that I use are checked in. I have one that works with the 1.6 SDK and one that works with the 1.7 SDK. That's what we're using right now. If I get the advanced properties, I could use that relative guy, or I could use the absolute. We'll just use the absolute for now. Let's actually give it a little bit more room. Okay, that's our publish script. We also need the subscription data file. That's that publish settings file that has the certificate and the keys. So we'll go back to the source code in Explorer. In my case, I checked it in because everyone who can see this part of the depot has permissions. You may choose not to do that. You may choose to have it in a lockbox or in some place on the build server that only truly the build server process can see. So this is a place where you might want to think about securing it. So we'll grab the properties for this guy. We'll put them in. All right. And then what we want to do is just choose a place to deploy it. So how about we will use the staging slot in this cloud service since it's free. And then we want a storage account that's in the same data center. So I think I just created a West Europe. Yeah, there's one. somewhere here in Amsterdam. We'll grab that. And now, took a few steps. I mean, setting up automation isn't the quickest, most glamorous thing, but that's actually all we really need to do. We just set those parameters. We dropped in the XAML workflow file. We dropped in the PowerShell into the depot. And we're actually good to go. So now I can come back to my builds. Actually, let's do it the real way. So we'll make a change to our source code. All right. We'll check it in. All right. Now if we look at the builds, we can see that triggered the continuous delivery build already. We're going to wait for the refresh. Man, I want that explicit refresh. That'd be cool. All right. And just one kind of cool implementation detail. As a part of that workflow activity, we take the standard PowerShell output and we pipe it right into your input, into your build definition. So now your standard TFS build output will have all the same kind of powerful output coming from Azure. So we'll see that hopefully in just a sec. So we did the build portion. That's done. And still complaining about the connection string. Maybe I should have fixed it. Just a second longer, we should see the deployment kicking off. There we go. And here's the same exact output of the publish, and it's actually kicked off. Now let's just wait here for 10 minutes and see it in Azure. Just kidding. I won't make you do that. Okay. And as I mentioned before, that script is actually aware of publish upgrade. So if I publish the same app to the same slot, by default, it will do the in-place upgrade, which is cheaper and won't destroy your VIP. And if you actually don't like that, there's just a little flag that you can pass in the PowerShell, and you can always do a delete and always do a new deployment. Any questions on that? Pretty easy? Okay. Yes, sir? Yeah, the TS service is the same, but it's quite a bit easier to set up than I just did. We just did a bunch of assembly by hand. Actually, if you, I think I have 7 minutes left. I'll show you. Let's do a demo. So actually, well, that's a perfect segue. You predicted it. So let's just talk about the cloud elastic build service that we have for TFS, how it's a little bit similar, how it's a little bit different. You can set up TFS publishing entirely using the Azure portal, and we have a wizard that makes it a lot easier just to get through all that stuff. And you don't need to get, kind of PowerShell scripts or build definitions and wire them all up yourself, because we're going to create them for you as an output of that going through that wizard. And just incidentally, my team worked with the TFS team to kind of take the best practices that we figured out on-prem, put it into the cloud. Now we've shipped it into the cloud. We're going to bake that, and then we're going to productize what we did in the cloud back on premise. So it's kind of this cool. We're even doing a little bit of continuous delivery ourselves internally. And then, so we're going to get all these artifacts by default. You're going to get a full-blown build definition that has activities that know how to publish to Azure Cloud Services and to Azure websites. So maybe you want to use either compute container, and it works the same for both. It will automatically set the solution to build if it finds one, and you can always override and say, oh, use a different solution to build. And then we'll automatically set the continuous integration trigger, but you can set it to whatever you want, manual, rolling, timed, whatever you want. So that's all stuff you can customize. So let's take the remainder of the time and give that a shot. So what I'll do, let's kind of get oriented here. So I have Here's my Azure account, and let's actually quick create something new here. So we'll call this TFS CD, and we'll do it in West Europe with my subscription. And we'll see actually in this kind of dashboard that we have a really easy command to set up TFS publishing. And I just want to check at one other thing because I haven't looked at it in a little bit. But I've already created a TFS preview account, and as you've seen in the announcement, this is open now to everyone. You don't even need an invite code. You can go get your TFS preview account right now. Check it out. I don't know the pricing, but I'm sure all will be revealed soon. And then what we'll do is we'll create a team project, and I really hope this is a lot faster than it was on premise. So we'll kind of get through this. And now that we've done all those steps on premise, it makes you appreciate what it's doing right now in the scroll bar. So we don't have to do all that stuff ourselves. Be feeling bold? Maybe we'll start the other wizard and we'll just see if we can meet up at the same time. So we're going to set up TFS publishing. We're back in the Azure portal, right? And the way that we did this is you start from the Azure portal and you connect it to your TFS service through the TFS portal. In the future, we actually want to enable the reverse direction also, so you could start in the TFS portal and then connect it to Azure. Just for timing reasons, we only did one direction, but you get the same end result. You basically have two services that are aware of how to talk to each other. And as is standard today, to get two completely different services to talk, we're going to use OAuth so that there's a secure channel between the two services, and just the right amount of permissions will be opened up so that your TFS account can publish into Azure and provide your build and publish history to Azure. But it's not, it doesn't have more authority than that. So we'll say Waverton, because that's the path, and we'll start authorizing. This is where we're going to do that OAuth handshake. Might actually force me to log in again. We'll sign out. Oh, that's right, because it's a different account, I think. Is the cloud sad today? What's that? Oh, I did. Thanks. So that's just a bad error message. Ah, you rock. Okay, I'm going to take a note of that. We'll go fix that tonight. Bad error message. Shucks. Let's try one more thing. You can see it's here. Wow, it actually looks like my STS is down. I can't. It looks like our STS is down. That's probably happens 8 hours a year. Okay, that was bad luck. But do I have another one? Aha. So I've done this before, and just like Julia Childs, I could pull one out of the oven, right? This is actually talking to that Waverton online service. And what you would have seen is that this build definition gets created just by default with the trigger set to CI. And if I go to the process template, so up in TFS, we now have this continuous deployment XAML that is totally aware of how to work with your cloud service account or websites. And you can even see it even nicer than I did in my workflow. This TFS one has really nicely named properties. It's in its own publishing section, so it's really clear. And you can just see that we went the next mile in the service. And so that's basically it. You don't even have to think about it. You just go through the wizard, and assuming that Microsoft.com is online, then you can, off you go. So that, I think, takes us to the end. We actually got all the way through absolutely everything. So just to summarize, with these tools, you'll be able to automate the complete delivery process. I actually didn't show it, but you can even, if you have unit tests, that build definition will run your tests. So we did the build, the test, and the deploy. It integrates with every step of your app lifecycle. And it's flexible to the unique requirements that you have, right? Whether it's different build systems that you have, different test runners, different frameworks. And the complete guidance, I have a link for you here for on-premise versus TFS is there with a complete code. And I'm also going to be here all week, so I'd love to talk to you guys, hear about what you're really trying to do, hear if this approach works for you. You have my email, too. It's paulyuk@microsoft.com. Kind of an unfortunate email, but you can email me anytime. I'd love to hear how it's going, see if we can help you guys. So with that said, thank you very much. Thanks for your time. Please check out the related sessions that we have, and remember to send the evals. The 5s are for my boss. The comments are for me. So I think, yeah, here we go. Okay, thank you very much.